It's the integral from a to b of f of x dx, correct?
Or f of x minus 0.
Exactly. What you're actually doing is this. You are subtracting that lower function from it.
Yes.
So for example, could I introduce a g function? Sure. I could take g, and here's g. If I wanted to find this area right here, how would I do that?
Well, it's like the 0.
Replace the 0 with the g, exactly. So this is just f of x minus g of x. So the areas between curves you've actually already done. It's just you're subtracting something below. You just have to watch out for a couple things that can happen. For example, let's say f is traveling along like this, and let's say g is traveling along like that. Could that be two cubic functions?
Mm-hmm.
Absolutely. So let's say, for example, this is f of x. Let's say this one is g of x. Let's say I wanted to find the area enclosed by. That's a common phrase. The area enclosed by. So here it is. Here's the area enclosed by the two curves. What do I need to find first if I'm going to calculate an integral? What do I need to find first? The 3 points of intersection, exactly. So let's say that this one was x equals a, this one was x equals b, and this one was x equals c. How many integrals do you see?
2.
I see 2. The first one here is going to be the integral from a to b of what? F of x minus g of x. And what's the second one going to be? Exactly, b to c of g of x minus f of x.
You need to check the points of intersection every time for any time they ask you for.
If you're integrating across multiple areas, what you're looking, if the upper and lower flip, you're going to have to. If the upper and lower flip, because here's the thing. If I just calculated, here's a question for you. If I just calculated the integral from a to b of f of x minus g of x, you would get this, but then what would this become?
Negative.
So you'd actually be taking this and subtracting this. So let's say this area was 7 and this one was 6. Instead of getting 13, what would you get?
1.
You'd get 1. So just be careful. Sometimes the upper and lower can switch, and that is absolutely something that can happen on the AP. So what's the best first step for number 2, especially at the beginning?
Find out what it is.
Yeah, well, what am I doing right now?
Draw a picture.
I'm drawing. Draw a picture. So you have y equals the x squared, correct? And then you have 2x minus x squared. When x is 0, what's y?
0.
What?
0.
0, right? Sure. It's like this. But then where else does it cross? The x-axis, I mean.
X equals 1.
X equals 1?
2.
No, 2.
2.
2.
Oh, yeah.
So you have a parabola that kind of looks like this, correct? Drawn pretty poorly.
Yes.
So what region are we looking at? We're looking at this enclosed region right here. So what are we aiming for first? What should we find?
Points of intersection.
Yeah. What's that first one? The first one's nice. What is it? Yeah.
Second one's also pretty nice.
Is it? Does it work out pretty nice? Yeah, what is it?
1.
1 what?
I don't know.
Plug in 1, what else do you get out?
1.
1. Yeah. It actually doesn't matter, right? You don't need it.
Really doesn't matter.
But you might. You might. And you're going to need it because I'll show you. Anyway, so what integral are you doing here? You're doing the integral from 0 to what?
1.
0 to 1 of 2x minus x squared minus x squared
Awesome.
times dx. And can you evaluate that integral? Yeah, absolutely. Now, what do these rectangles look like here? Here are the rectangles. Always remember what the rectangles look like. Here they are. Here are all the rectangles that you are adding up, just as a side note right there.